This lesson is over concavity, points of inflection, and the second derivative test. First, we're going to look at concavity and points of inflection. We have this function here. F of x is equal to x plus 2 times x minus 4. Simplified version is right there. On what intervals is f of x concave up? Well, I'm going to look at this. I'm going to get an estimate first. And if I look at a graph here, I'm not sure if you can actually see this or not. If you look at the graph of this, it looks like it's going to be concave up till right about here, 1 or so. So it's concave up. It's concave up from there on, and it's concave down up until then. So we're going to start with just an estimate here. I'm going to say it's concave up from approximately 1 to infinity. Concave down from negative infinity to 1. So the point of inflection, or change, we're going to say it's approximately 1. Now, we will come back to all that information here. When I go to fill in the table down here, here's what's going to happen. So I fill in the table with all my f prime values. So the derivative at negative 5 is 87, derivative at negative 4 is 56, etc. So it's positive, which means the function is going up. Then somewhere between negative 2 and negative 1, it's going to be 0, because then it becomes negative, so which means it's switched from increasing to decreasing. And it's decreasing. And it's negative, 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 and then it switches from negative to positive again. So it's going down, and then all of a sudden starts going up, which means this is, if you remember from the first derivative test, this is somewhere in here is a relative minimum. Somewhere in here is a relative maximum, because f prime changed from positive to negative, and f prime changed from negative to positive. We know it's concave up from 1 to infinity, or from concave down from negative infinity to 1. If we look at the second derivative here, here's what happens. From negative infinity to 1, all these numbers are negative. From 1 to infinity, all these numbers are positive. So what do we notice about the f prime values, f double prime values when f is concave up? When it's concave up from 1 to infinity here, we know that these are all positive. F double prime of x is greater than 0 when f is concave up. What do you notice about the f prime values when f is concave up? So I'm going to come back and look at this. We've got negative 4, negative 9, negative 4, 7, 24, 47, 76, 111. All of these are increasing. So what do we notice about f prime values when f is concave up? F prime is increasing. Similarly, what do I notice about the f double prime values when f is concave down? Well, it's concave down all the way up until somewhere in here. So all these values are negative. So f double prime of x is less than 0 when f is concave down. What do I notice about the f prime values when it's concave down? I should say down. (87, 56, 31, 12, negative 1, -8, -9. All these numbers are going down. F prime of x is decreasing when f is concave down. So that's the way that you can tell using a chart when something is concave up or concave down. If it's concave down, the second derivative is negative, or you can also say the f prime values are all decreasing. When it's concave up, the f prime values are all increasing, and the second derivative is all positive. Flip our paper over here. How can we do this using a graph? Well, I've got a graph here of f. I also got a graph of the first derivative and the second derivative. On what interval is f concave up? Well, it looks like it, we already said, it looks like it's from about negative infinity to, from 1 to infinity. What do I know is about f prime on this interval? From about 1 to infinity, well, look, it's increasing. F prime is increasing. What do I know is about f double prime on this interval? From here to here, all these numbers are positive. F double prime is greater than 0. So f is concave up when f prime is increasing and when f double prime is greater than 0. This makes sense though, because if f prime is increasing, the derivative of this right here, all these slopes would be positive. So just like the first derivative, it also applies the second derivative. On what interval is f concave down? Well, we're saying approximately from negative infinity to 1. What do I notice about f prime on this interval? F prime is decreasing. And what do I notice about f double prime on this interval? All these values are negative. So f is concave down when f prime is decreasing and f double prime is less than 0. And we say and, but it's really both of these things happen at the same time. So if we think about it here, let's flip back to the front. How do I find a point of inflection? It happens when the second derivative changes from negative to positive. So it's going to happen somewhere in there. Well, how do I figure that out? Same way I did finding maximums or minimums. Find the point of inflection. I'm going to take the second derivative and set it equal to 0. I go to solve this. And reduce, it's 2/3. And if I pick points around that, what's f double prime of 0 when f double prime of 0 is -4, so it's less than 0. F double prime of 1 is 2. That's greater than 0. So we can say f has a point of inflection at x equals 2/3 because f double prime changes signs. So that's where the point of inflection occurs. There's another way to figure out the point of inflection, though. When does f have a point of inflection here? What do I notice? We just said it's at x equals 2/3. What do I know about the f prime value at this point? Well, 2/3 has to be right here. That's a minimum, isn't it? And it would also work for maximum. So what do I know about f prime at this x value? F prime is f prime has a relative minimum or a relative maximum. We could also say the derivative of f prime is 0 undefined. What do I know about f double prime at this value? Right there. That point of inflection where it switches from concave down to concave up. What do I know about the f double prime at this value? F double prime is going to be 0 or undefined and changes signs. So it's going to change from positive to negative or from negative to positive. So f prime has a point of inflection when f prime has a relative max or relative minimum. Or you can also say when f double prime changes from positive to negative or from negative to positive. So right there. What do I notice about concavity of f when it has a relative maximum? Let's look at this right here. F has a relative maximum right here at 1.097, I believe, if I remember correctly. It's got a relative maximum right there. And it's got a relative minimum right there. But at this point right here, it's concave down, isn't it? So what do I notice about the concavity of f when it has a relative maximum? F is concave down. Or we could also say f double prime of x is less than 0. When it's got a minimum, which is happening right here, f is concave up. And when it's concave up, we learned that f double prime of x is greater than 0. This is called the second derivative test. So when f has a relative maximum when f prime of x is equal to 0, and when f double prime of x is less than 0. And when f double prime of x is less than 0, that's another way of saying it is concave down. F has a relative minimum when f double prime of x is 0 and when f prime of x is greater than 0, which is another way of saying f is concave up. Second derivative test isn't used too terribly often, but it does come up on the AP exam. It's basically just a simple way, though, of saying if you're not sure if it's a minimum or maximum, but you know the derivative is equal to 0 at one of those points, if you can figure out the concavity, that can tell you if it's a minimum or maximum. So So it's concave down and derivative 0. Oh, it's got to be a maximum. Or here it's got to be a minimum. All right, that's the notes for this section. Once again, to sum up, if you got a table and you need to figure out when something's concave down, it's concave down when f double prime of x is less than 0. It's concave up when f prime of x is double prime of x is greater than 0. So those happens f prime of x is decreasing, and then switches to increasing. Decreasing concave down, increasing concave up. Looking at the graph here, f is concave down when f prime is decreasing, when f double prime of x is less than 0. F is concave up when f prime of x is increasing, or when f double prime of x is greater than 0. Points of inflection occur when f prime has a minimum or a maximum, changes from decreasing to increasing or increasing to decreasing, or when f double prime changes sign, from negative to positive or from positive to negative. Thanks for watching. Good luck on the homework, and I'll see you soon.